Let's take a look at question 3 here. It says, which one of the following compounds is consistent with the following infrared spectrum? So the first thing I would do is I would draw a line around 1700. So this is 1500 and here circled. So this is 1700. So that first thing I can see is that I have no carbonyl stretching. No carbonyl present in whatever molecule is being represented by this spectrum. So therefore, if I go down to my choices, I can eliminate anything that possesses a carbonyl. So that eliminates 3 of them right away. The first one possesses a carbonyl. The second one possesses the carbonyl and a carboxylic acid. Also, for number 2, I would point out that for a carboxylic acid, there's no broad stretch going from 3300 to 2400, so it's obviously not a carboxylic acid. Also, it eliminates number 5, because number 5 is an aldehyde which possesses a carbonyl. Also, we don't see the aldehydic stretching at 2850 and 2750, so that narrows it down very quickly. Just by knowing that there's no carbonyl stretch, that narrows us down to numbers 3 and numbers 4. And if you look above 3,000 reciprocal centimeters, so if I look above here, you can see there's a big broad stretch here. Big broad stretch, and you see that's around 31, 32, 33. So it's around 3350. So this is an OH stretch. So that comes from an alcohol. So that big broad stretch, very strong stretching around 3350. So again, if we go back to our 2 remaining choices, you can see that they both have the hydroxyl, so they should both have that signal. But if we turn our attention to other signals that we see in here, you can see that there's a strong stretch, or I guess a medium stretch. I shouldn't have said strong. It's a medium stretch here. And this is around 1630. So this is around 1630 reciprocal centimeters. So that comes from a carbon double bond stretch. So 2 sp2 hybridized carbon. So that's an alkene stretch. Also, so that automatically you can see that it must be compound 4. But what other signals might we see from compound 4? Well, since you know bond line structure, you'd know that not only is there the carbon-carbon double bond, but there's also the sp2 hybridized carbon-hydrogen bond. And that gives us a stretch around 3100 reciprocal centimeters, and you can see that stretch right here. So this is the S, so I'm going to put sp2 CH stretch. If I just wrote carbon-hydrogen stretch, it does not provide me with enough information. Because if I have an sp3 hybridized carbon-hybridized stretch, well, that's going to be anything here, just below 3,000 reciprocal centimeters. If I have the sp2 hybridized carbon-hydrogen stretch, that's around 3,100. And if I have an alkyne, the carbon-hydrogen stretch should come around 3,300 reciprocal centimeters. So I don't have that, and it's not one of the choices anyway. So that means that this spectrum must be compound 4. So we did it, again, partially by process of elimination and also by examining the functional groups present in the molecule. So clearly we have both an alkene and an alcohol, and they're present in our infrared spectrum.